Hello students. Today we shall learn about an interesting topic, linear programming. So linear programming is one of the technique in optimization problem. Here it is concerned either with minimization of cost or maximization of profit. So the LPP is an economic tool which was first developed and applied in 1947 by Professor Danzig. The optimization problem can be approached in two ways. One, by using differential calculus. Another way is by using linear programming. When we look into the linear programming problem, it involves three ingredients, essential ingredients. Number one, objective function. Second is set of linear constraints. Third is non-negativity conditions. So an LPP problem has to have these three essential ingredients in it. So this problem is referred to as linear programming problem because the objective functions, constraints and linear are linear in nature. Okay, so when we see into the general formulation of LPP problem, that is it has a objective function, then subjective condition and the non-negativity conditions. Now next is duality theorem. So in an LPP problem, any maximization problem can be converted into minimization problem. Similarly, any minimization problem may be converted into maximization problem. So let us have a look on the problems. In example 1, given primal problem or original problem, maximize z is equal to 3x plus 4y subject to x plus y smaller than or equal to 450. 2x plus y is smaller than or equal to 600. So non-negativity condition, x is greater than or equal to 0, y is greater than or equal to 0. So we can convert this primal problem into dual problem by this way. We can like instead of maximization, we can write minimize. So minimize cost C is equal to 450 W1 plus 600 W2 subject to W1 plus 2 W2 smaller than greater than or equal to 3, W1 plus W2 greater than or equal to 4, W1 greater than or equal to 0, W2 greater than or equal to 0. So we can write this into a matrix form as 1, 2, 1, 1, W1, W2 is equal to 3, 4. Another problem is, another example, primal problem is given as maximize z is equal to 3x1 plus 4x2 plus 2x3, then subject to x1 plus x2 minus x3 smaller than or equal to 4, 2x1 minus 4x2 plus 3x3 smaller than or equal to 7, and non-negativity condition x1, x2, x3 is greater than or equal to 0. So we can convert this primal problem into dual problem like as minimize C is equal to, we can take this 4 and 7 into the objective function as 4y1 plus 7y2, whereas the subjective condition, which is in the form of row, is converted into column. That is, instead of x1 and 2x1, it is written as y1 plus 2y2 greater than or equal to 3, y1 minus 4y2 greater than or equal to 4, minus 1y1 plus 3y2 is greater than or equal to 2, y1 y2 greater than or equal to 0 is the non-negative condition. We can write this as into a matrix form 1 2 1 minus 4 minus 1 3, y1 y2 is equal to 3 4 2. So this way, in this way we can convert the primal problem into dual problem and dual problem into primal problem. Thank you.